Hello everyone and welcome to the part 3 of DevOps monitoring with Prometheus. In this part, we are going to take our third question, that is, what are the four golden signals of monitoring? Okay. Now, if you have read the book about the Google Site Reliability Engineering, which is absolutely must, then you can answer this question. Otherwise, we are going to discuss this in more detail over here. Okay. So there are basically four golden signals which helps us in the case of the observability, and this represents basically our minimum set of metrics which we should be monitoring within our user-facing system. Okay, and these signals actually provide us a comprehensive view of the overall system health and the experience. So why the golden signals matter? Because every organization is focusing on the user experience, and these metrics actually directly correlate with that. Okay, so it provides you a universal application. It allows you the user experience for these applications by virtually having it can be implemented across any system. Okay, and it has proven effectiveness, and it has been used by the major companies like Google. It has balanced coverage, that is, it allows you to have a comprehensive system health overview. So we are basically dealing with the four golden signals here. What are these four golden signals? The first one is basically the latency. Okay, and latency has to deal with how fast is your system actually working. So it basically is the time which is taken by the request, and it's typically being measured as a response time. So let's say you go to a google.com, how much time does the google.com load for you? That is basically the latency of the website or the application from which you are getting the response. Okay, so why it matters? Because this directly impacts your user experience. Okay, so let's say, for example, if you were going for some web application which was having much slower, that is, let's say you were previously accessing from few years, suppose IRCTC website or something like this for the train bookings, and you would see that it takes a very long period of time. The longer the website takes, the user experience starts degrading because users don't want to wait. Okay, if they will assume that the website is not working, it is down, or it will forever going like this, and it is wasting their time. So the chances are the user might switch away, and that is how we measure the user experience. Okay, so the question comes, why the latency matters? Because it directly impacts your user experience. Okay, the user always, the first thing that the user is going to notice is when something is wrong. Okay, so this can be lying within your underlying system because it's a complicated system. It can be issue with your database issue, it can be a network issue, it can be a resource constraint which is affecting and increasing your latency for the web app or any other application in that sense. Okay, now the key considerations. So you need to distinguish between a successful and the failed request. Failed request can immediately return like 404 is different, and from a success request which takes around 5 seconds of time. Normally 404 is written when it does not find the proper web page or the page you are looking for. It returns a 404 saying request page not found, right? And so these kind of errors are immediately returned, while if you see the successful processing, there is a backend code which is actually processing the request, making some database entries and all, so there will always be some latency associated with it. Okay, now so you need to really distinguish between the two of them. You need to use percentiles and not average. Okay, because average is not that better. It does not give you that better result. So you always need to use the percentiles, and always use 95 to 99 percentile is more meaningful than average. Okay, so we need to consider the different request types, that is API calls, page loads, database query may all have different acceptable latency thresholds. So depending upon your application, you will need to establish this for the different types of requests which are being made to your application. Now, if we talk about the Prometheus implementation, you can implement the basic latency metric using something like HTTP request duration seconds. Okay, so it will measure how much time your request is taking. Okay, then I talked about the 95 and the 99 percentile that is also built into the Prometheus. You can directly use the histogram in that sense. So it will show you the histogram quantile. Basically, it allows you to check the 95 percentile of the request, and it actually checks. You can actually check over the rate over which your request was coming over a period of time. Let's say 5 minutes. Now, average response time by endpoint, you can check using the average function. So these are the different functions which are built into the Prometheus. Okay, and the most prominently, we are discussing the most prominently used. That is like average, histogram, latency. Okay, rate. So these are the most commonly used. The metrics within the Prometheus. So if you wanted to calculate the average response time, you can calculate using this. That is average response HTTP request duration of the second upon divided by the HTTP request duration seconds over the 5 minutes. So once you are taking of the sum of all the requests, then you are dividing it with how much individual request is taking and dividing by the handler. That way you can get the average response time. So you see there is some math which is involved here. This is what we have discussed in our previous like the videos also, that with Prometheus you have to do some math operations in this kind of calculation. Now, if you wanted to use an advanced latency, so you can go ahead and use the histogram quantile, and I have included that for you. In this case, we are checking the histogram quantile, that is latency, for the 95 percentile of the API, okay, as well as the web request. Then we are also checking the latency over a period of time, like that, okay. So these are the different queries that you can make using the Prometheus. And here is an example of the alerting example, that if 95 percentile is dropping, like it's greater than 2, then give out an alert for 2 seconds, right? So if a latency is increasing beyond 2 seconds for 2 minutes, then go ahead and send out an alert to it. In this case, alert manager will detect and send out the alert. Now, the first one we discussed is the latency. The second one of the golden signal is the traffic. Okay, so how much load is your system handling? Okay, that is what we mean by traffic. So it basically measures how much demand is being placed on your system, typically measured in requests per second. So that is how we measure how much traffic is coming to your application. Now, why it matters? Because it helps understand the system utilization. It is essentially allows you to have the capacity planning in place. It correlates with the other metrics, like high traffic might cause high latency. Okay, so if you are seeing let's say large number of requests which are coming to your application, even though your application tends to behave correctly, but it can have the increased latency, the golden signal one, because now the traffic itself is high. Okay, and this will indicate a business impact, because traffic drop might mean service issues or lost revenue. So that is something we wanted to avoid. We don't want to find ourselves in a scenario where the business loss is occurring because we are not able to handle the traffic on our application. Now, there are different ways to measure the traffic, like we can measure the HTTP request in case of web application. We can measure transactions per second in case of database system. We can measure messages per second in case of messages queue, because nowadays you will see queue is being extensively used. And then number of concurrent users that you need to handle. So these are the 4 major traffic metrics that you need to monitor. I will once again repeat it. That is HTTP request, transactions per second in case of database, messages per second in case of queue, and concurrent users for the real-time system. Now, how you are going to measure that? In case of rate, HTTP request, you can use the rate function for that, and it will calculate the request per second for you. And similarly, you can calculate the request rate by HTTP methods over a 5-minute period. Okay, by each method. Method means whether it's a get call, pull call, or like that, post call. You can actually divide by that. And similarly, you can get by the handlers as well. Now, advanced traffic analysis, you can actually calculate the peak traffic comparison. Okay. This will include your rate, that is your HTTP request, how many total requests were there, over like you are comparing it with the HTTP request total of 5 minutes offset over 1 week, like that. Okay, then you can also calculate traffic growth rate. So this is how you calculate the traffic growth rate and traffic distribution across the instances. So these are just the different ways of calculating the same thing, like how you are going to measure the traffic. And similarly, if you wanted to check the business impact metric, then you are going to look out for the revenue impacting request. Okay. When I say revenue impacting request, you need to check out for the endpoints like /checkout, right? This is important because in case of e-commerce, this is where the users are checking out. So we want you to check how many requests are there. So if any of these requests is erroring out, that means your business revenue is directly getting impacted. Then we also have user facing versus API traffic. So again, you can calculate like this. You can calculate the HTTP request for the user versus that of the HTTP request total for the API like that. So you can calculate how much user is accessing directly and how many are making the API call and then they are accessing like this. Okay. Now we are going to move towards the third golden signal, which is errors. Okay. In this case, you will see that errors basically deals how often do the things go wrong. Okay. So the rate at which your requests are failing is typically expressed as a percentage of the total request. And why it matters? Because it directly indicates your system reliability, okay, which is very important. Your system should be highly reliable. And secondly, it often is the most critical metric for the user experience. If your system is failing too much, then definitely your user experience is very bad. And it can reveal the system degradation before the other metrics show problem, okay? So definitely you need to keep a check on the errors. And it is also essential in SLA and SLO tracking, okay? So SLA is like service level agreements you need to provide, okay? And so similarly, this keeping a track of the errors is very important in that. So types of errors to track, we need to track HTTP errors, that is 4xx errors for the client side and 5xx for the server side errors. Then we also need to track the application errors, like some business logic failures might be happening in the application or the exceptions which are coming. We need to get those exceptions and check those exceptions while these applications are throwing it. Then there are infrastructure errors like network timeouts, database connection failures. So these also needs to be tracked, okay, in order to check the errors. So we have basically discussed the three. First one was that of the latency, and the second one is the traffic. The third one is the error, and the fourth, when you are checking this, these are some of the queries how you can get the 5xx errors within the Prometheus, how you can get the 4xx and 5xx errors over a period of time. And similarly, how you are going to do the detailed error analysis. So if I wanted to check the errors, this is how I can query the error rate by endpoint, error rate by service for each service, and the error rate between the different versions. Suppose if you are doing a deployment, whether your errors are reducing or increasing, this will allow you to keep a track like that. Okay, and then there is like advanced error tracking. You can keep a budget consumption. So let's say if our SLO is 99.99% availability, then we can track over a period of 30 days and see how our service is behaving like this. And similarly, if we are seeing the spike in the error detection, then we can actually check like this, that how much this spike is affecting our application. Okay, and the last one is golden signal is saturation. So what are the four of them? First one is your latency. Okay. Then the second one is your traffic. Third one is your error, and the fourth one that we are starting is the saturation. Now, what is saturation? So how full is your system? Okay. What that means is that how constrained your system is. Typically, it is measured with the utilization of most of the constraints, like different resources. So if those resources are getting full, that means your system is getting full as well. Okay. Why it matters? Because it predicts when your system capacity will hit. It is essential for auto-scaling decisions, helps in identifying the performance bottleneck. Okay. And helps you for the critical capacity plan. Now, this is very important to understand that you need to have a capacity planning in place, because as your traffic increase, you can trigger on the auto scaling, but then your there are different resources which is handling your traffic. So if they are getting full, that means you need to have a full indication into it, then only you can scale out. If you are not able to handle, then your traffic is going to cause the saturation, which is going to increase the latency and the error. So that's how all four of them are interrelated, and that's why you need to keep a system check for the full how full is your system. Okay. Now, the common saturation metrics are CPU utilization, your processor usage percentage. Okay. Next is your memory, how much memory your system is using. Disk utilization, is to deal with the storage capacity and the input output, your network bandwidth, okay, then your database connection pool, like how many connections database can handle in parallel, queue depth, okay. Queue depth is basically related to your queuing system. It tracks how many messages can the system can keep in a queue before it actually exhausts like this, okay. So again, if you want to implement in the Prometheus, this is how you can implement. For the CPU utilization, this is the way you can calculate the overall CPU utilization. For memory utilization, you can subtract from the one or overall memory. Disk utilization, again, this is how you can calculate the different disk utilization across the node. And for network utilization, you can calculate the rate, okay, of the network transfer bytes and the network receive bytes like this. You can actually calculate the overall network utilization. For the application saturation, we are talking about the database connection. So you can actually, suppose if you are using MySQL, you can calculate the global status thread connected and divided by the global variable max connection, and that's how you are going to get the total number of connections. Similarly, you can calculate JVM heap, queue depth, and stuff like this, which is very critical for your system. And if you wanted to have a predictive saturation analysis, then you can go into the predict linear. So predictive is like I wanted to predict what is the behavior based on my past performance. So suppose I wanted to predict when this will be full. So 4 hours from now, based on 1 hour trend, I can go on predicting like this. So there is a predict linear. It will show you the graph for it. So this is how you can actually predict in the basis of Prometheus. Now, memory usage growth percentage. So this is how you can actually use the derive. This derive function is going to calculate your memory. It will look for the events and show you when your memory will be getting full based on the previous. Now, bringing it all together, golden signal dashboards. So suppose if you wanted to create a golden signal dashboard, these are the 4 major things you need to keep into the mind. So you need to have a latency panel, then you need to have a traffic panel, then you need to have an error panel and a saturation panel. And you are going to use the histogram in case of the latencies. You are going to use the sum for the traffic, like overall traffic. Then errors, you are going to calculate in terms of the sum, and the saturation you will be subtracting and calculating using the average saturation of your resources. Now, based on this, you can create an intelligent based golden signal. So here are some of the important signals that you can create, like high error rate and high latency. If this is something, this is like obviously giving multiple signals, which we are concerned about. And similarly, we can create high saturation with increased traffic, right? So if our resources are getting occupied, that means higher saturation is happening. Now, business impact correlation. So we can check out the critical traffic, like if something is affecting our /checkout and stuff like this, we can that is our revenue impact. Okay, so if you see, the 4 golden signals basically provide us with a foundation of a reliable monitoring, but remember that they should be supplemented with the business specific metrics and deeper observability practices and comprehensive system understanding. Now, this is very important that overall these 4 are very critical, but then these are not the only ones. You need to have a keen understanding about the business and the business specific metrics which are there, because ultimately our whole goal is to prevent the business loss, and that's where this metrics will come into the picture. So we need to have a deeper understanding of the observability in order to overall implement. But these are the 4 major golden signals, and these are very common to be asked within the interview. So you need to know about these 4 golden signals. Okay, that's all for this video. See you in next video. If you like our video, do subscribe to our channel, and all these notes are available directly on our blog, unixcloudfusion.in. You don't need to copy all this like queries and all. These are all available in our blog, so you can go anytime and go and take a look over there and revise all the things at your own pace. That's all for this video. Signing off. Thank you.